So we're still working with words and math this week as we look at Module 4, Lesson 16. Today we're going to actually write the mathematical expressions. For written descriptions. So let's see if we can kind of start getting into this a little bit. So let's go ahead and jump past the first page here and see what we got. So the first thing I want you to do is I want you to go through these examples. I want you to annotate them for what each of them means. So for example, in this first one, it says the quantity y increased by m doubled. So the quantity y increased by m. So first, increased by makes me think addition. Doubled makes me think multiply. Specifically, it makes me think multiply by 2. I don't always know that, but here I would. So I want you to go through these examples. It take maybe about 1 or 2 minutes to do this, and just annotate each of these for the operations that you see. Let's start with this. Take 30 seconds, go through A, B, and C, and then come back and check A, B, and C in about 30 seconds. Okay, so 30 seconds is up here. Let's go ahead and take a look. The sum, that means addition, of twice B, that means 2 times B, and 5. So let's see here, the quotient of C and D. Quotient means division, so that one's pretty simple. And then C is A raised to the 5th power, so that would be an exponent. And then increased by, that's addition, the product of 5 and C, and that, of course, is multiplication. So now, using what we just did, kind of as another example, pause now. Take 30 seconds, try D, E, and F on your own. And hopefully now you're back. I'm going to say the quantity of A plus B. So here, this one, I can actually do 2 things here. I can say this is parentheses, but I can also say it's addition because of the word plus. And then divided by 4, that one's not too bad. That one's obviously division. All right, let's keep going. 10 less than the product. Well, first of all, that's minus 10. And the product of 15 and C, that's multiplication. And last one, 5 times D, then increased by 8. 5 times D, that's definitely multiplication. Increased by 8, that's obviously addition. So we've got all these labeled. Hopefully that'll kind of get our brains going as we try to write some of our own expressions today. Okay, so let's look at this first one. These are obviously real-world situations, so it's going to be kind of strange. So Marcus has $4 more than Yassine. If Y is the amount of money Yassine has, write an expression to show how much money Marcus has. So again, the most important information we know is $4 more than Yassine. So first you want to ask yourself, $4 more. What operation does that suggest? Well, it probably suggests addition. It could be subtraction if we experimented around with it a little bit, but I think it's probably addition. So let's try this. So we know Y, if we label what people have here, Yassine, and I guess Marcus. So start to break this down. Let's say Yassine has $2. If she does, Marcus has 4 more, so he obviously has 6. So how did we do that? How did we figure that out? What was I thinking to do that? I was thinking 2 plus 4. What if Yassine has $0? Well, obviously Marcus has 4. How did we figure that out? We thought, what's 0 plus 4? So what if she has Y dollars? Well, obviously if she has Y dollars, Marcus is going to have whatever Y plus 4 is. But we don't know what Y is, so I'm going to say this. I'm going to say let Y represent the amount of money Yassine has. The amount of, let's abbreviate, money Yassine, capital Y, Yassine has. And if that's true, then my expression must be Marcus's expression must be Y plus 4, because we know he is Yassine's plus 4. Let's keep going, see what we can do. All right, now let's try this. It says Mario is missing half of his assignments. If A represents the number of assignments, write an expression to show how many assignments Mario is missing. So we know he's missing half of them. If he's missing half, first let's think about our variable. A represents the number of assignments, right? So let's see assignments, and I could say the ones that are missing. And let's just pick a few numbers and try it. So it says he's missing half of his assignments. So let's say he has, 20 assignments. If he has 20 assignments and half of them are missing, that means how many would be missing? That would mean 10 are missing. So how did I do that? How did I figure that out? Well, I was thinking 20 divided by 2. Let's try again. What if he has 12 assignments? Obviously, how many are missing? 6. So how do we do that? Again, we're thinking 12 divided by 6. But we only know that he has a number of assignments. A number of assignments. So if he has a number of assignments, that means it's a divided by 2. But we learned a better way to write this. Instead of this, I'm actually going to write a over 2. So there's my expression, a over 2. And I got that from kind of going through a series of steps. First, I read through and I annotated the problem just like we did. Then I made a table trying out some numbers. And then finally, I actually tried to write my expression. So that's our expression, that's our answer. But let's codify what we did. So first things first, we read the problem. We read and annotated the problem. Then we did this thing I like to call GoovGen. GoovGen is a really, really weird word. Basically, it means get out of variables, get into numbers. So this is a really weird step. That's what I did here when I was like, well, I don't know how many assignments he has, so I'm just going to say 20. I'm just going to pick a number. You could have picked 100, anything like that. And then finally, we actually wrote our expression. So sometimes we might need to GoovGen, which is this step right here. You might need to GoovGen to figure out your answer. So let's go ahead and I'll help you a little bit more with the next one, and then I'm going to expect you to go on without me. So it says, Camilla's weight has tripled since her first birthday. If W represents the amount Camilla weighed on her first birthday, write an expression to show how much she weighs now. So let's start, well, we just read it, now to annotate. Tripled since her first birthday. That makes me think multiplication. Specifically, what kind? Times 3. Times 3. And W is how much she weighs on her first birthday. So right now, all we've done is we've read and annotated the problem. Now let's GoovGen. Let's just try some stuff and see what happens. So we need a birth weight as a baby, and then now. So it says it's tripled since then. So let's say she was born at 7 pounds. If it's tripled, that means now she must weigh 21 pounds. So I'm thinking, how did I do that? I'm thinking 7 times 3. Well, what if she were 8 pounds at birth? Then she would be 24 pounds now. How did we get that? We're thinking it tripled, 8 times 3. So, but we don't know this number. It says if W represents what she weighed on her first birthday. So if W is what she weighed, now we don't know what W is, but it's whatever W is times 3. But we know a fast way to write that. We can write that as 3W. So what's my expression for Camilla's weight now? Camilla's weight now must be 3W. That's how we can represent it. 3 times what she used to weigh. All right, now here's what I want you to do. I want you to try 3 on your own, doing some of our same steps, and then pause it and come right back and see how you did. All right, on this one it says that he brings these 5 cupcakes to school and he shares them equally with his 5 best friends. And C is the number of cupcakes he brings to school. So let's think about this. Cupcakes, and they're going to share them, right? Each friend, how much is each friend going to get? So obviously, if he brought 5 cupcakes, each friend gets 1. How did we figure that out? We're thinking 5 split into 5 parts. Let's say he brought 10 cupcakes. If he brought 10 cupcakes, he's giving them 5 friends. Each friend's getting 2. How are we getting that? We're thinking 10 divided by 2. So obviously, if he's got C number of cupcakes, it's going to be whatever C divided by 5 is, or I'm going to write that better, C over 5. So my expression here is C divided by 5. All right. Well, let's do this. Let's see if we can cram one more example into our video today. If we can't, no big deal, but I want to see what we can try to do. I think that I want to see if we can try number 5. 5's a good challenging one. Go ahead and try this one. So read through it, annotate it, GoogGen, see what you can do, write that expression for what we're looking for. Okay, so this one's pretty complex. It says 4 times as many free throws. So 4 times as many, I'm thinking 4 times as many free throws. 4 times as many jump shots. So both are 4 times something. But F is going to be the free throws, right? J is going to be the jump shots that he shoots. We want to show how many shots he will need in order to improve his basketball. So he has to do this and this. So we're going to combine those, right? If we're combining these things, the free throws and the jump shots, we're probably going to be adding them. So I'm thinking 4 times the number of free throws I could write for F, right? So there's free throws. But then we also need 4 times the number of jump shots. That's going to be right here. So if I want the total number of shots he's taken in a day, well, first let's write these shorter. I can write this one as 4F. And this one I can just write simply as 4J. If I want to find the total of those, the total shots needed would simply be 4F plus 4J. So there's his expression that models his situation.